Hello and welcome to the second lecture in the R tutorial video series for Professor Kozak's class. Today I'm going to be teaching you guys about variables and data types. So first of all, a variable is basically a way to store data. So for example, y is 1 or x is 1, y is 2 are variables. And there's two ways to set variables. There's two variable setters. So there's going to be this arrow function like I've shown. X is 3 again, or there's going to be this equals thing, which is so both of these are ways to set variables. The arrow function is the most common one, I think, but they're essentially the same with some very minor differences. We're not going to get into those differences until we get to functions, so for now you can use them interchangeably. Now we need to talk a little bit about variable names for a second, because this is pretty important. So in general, you cannot start a variable name with a number or a special character, but you can't. So the only thing you can start a variable name with is a alphabetic character, but you can use numbers after that. So for example, when S didn't work, but S1 will work, and you can interchange variables and numbers in any way after that first character. So, but you cannot use special characters even if you start a variable with the name with a alphabetic character. So for example, that's also determined. So okay, now that we know the way the format for variable names, let's talk about some conventions of variable names. In general, it's best to use longer, more descriptive variable names, because it's going to be easier for someone to come along and understand what's actually happening. For example, setting x equal to 20, it's going to be, when I go back and look at this code, I'm not going to be able to tell what x was. But if I were to say something like, since now that's going to be a lot more clear to me what that variable is actually holding. And so you may, when you're looking at a script, you may be able to determine what a variable is doing, even if the name is completely off. But it's a lot easier on someone else if they're coming and reading your code. And it's a lot easier on yourself when you come back to your code if you use these longer, more descriptive variables. And ultimately, it's going to save you a lot of time to do that. So in general, we prefer descriptive names that describe exactly what the variable is doing. Okay, so now we've talked a little bit about variables, let's get into data types. So the first data type that we're going to be talking about is the numeric data type, which is essentially anything that is a number. So x is 2 is a numeric data type. Y is 1.5 is a numeric data type. Z is 1 e to the 5th, or 1 times 10 to the 5th is a numeric data type. And fractions are also numeric data types, so 7/3. R is like a powerful calculator, so it's going to convert that fraction into a decimal value, into a decimal number for you. But with numeric data types, you can do basic math with them. So there's a couple of operators. There's 5 operators we're going to talk about here that you can do with numeric data types, that you can use to manipulate numeric data types. So for example, the first one is the plus, which is just going to add 2 variables, or a variable and a number, or 2 numbers. The next one is subtraction, which will let you, you can do that with which is going to subtract 2 numeric data types from each other. And then there's also the star operator, which is going to be multiplication. So 2 times 1.5 is 3. Then there's also division. 2 divided by 1.5 is 1 1/3. And then there's the exponentiation operator, which is essentially like x to the power of y. So that's going to give some fraction, but let's say, for example, we set x is 2, y is 3. X to the power of y is going to give you 8, because 2 to the 3rd, or 2 times 2 times 2 is 8. There are a lot of other operators you can use for numeric data types, like the modulo operator, or a bunch of other ones that you might want to do, like rounding and stuff like that. But in general, we're going to cover only other types of operators. You're going to have to look them up and learn about them yourself. And if you're having trouble with some of them, feel free to email me and I can sort of explain how they work or how to use them. Okay, so that's the basics of numeric data types. Now we're going to get into strings. So strings are another type of data type that is just a collection of characters. And a string is denoted by quotation marks and the characters you want. For example, this string, pi is good, is denoted by these double quotation marks. That's a string. You can have them be one word or one word or multiple words. So that's also a string. You can have them be any collection of characters. For example, a string that's just a set of numbers. So 1, 2, 3, 4, 5, 6. Important to note there that I use single quotes for this. You can use double quotes or single quotes to create a string. You can do a combination of numbers and alphabetic characters or alphabetic or letters, such as 1A, 2B, 3. That's also a string. You can also use special characters or combinations of special characters. For example, this is a string. So, okay, those are all the different types of strings you can create. It's important to note, though, that a string that's made up entirely of numbers is different than a numeric data type. So, for example, I can't do this won't work as expected. Actually, it's just going to throw an error. But you can convert a string that's entirely numbers back to a numeric data type by using as.numeric. That's going to return back to a number, so I can add 1 to that, and that will work as expected. Now, you can't use this as.numeric function on strings that are, say, a string that is a combined string, or any string that really has letters in it. So what you're going to want to do, and this is only really important for if you need to, if you need to parse out a number in a sentence or something like that. Another important thing about strings is that you can find the length of a string by using the char function. So, for example, the string apple has 5 characters in it, and this will be sort of important for the next thing, which is indexing through strings, which is finding say I want to get the first character of the string of this another string variable. So the way I would do that is I'd use the substring function, which basically takes as pass it the string you want to get the substring of, the starting location, and the ending location. So for example, 1, 1, or another string, 1, 1, you get the first character of the string. Ending at 2 would give you the first 2. Ending at 3 would give you the last 3, or the first 3. And I could say go 3 to 5, which would give me the 5th characters of it. And this can be important if you want to parse out what, like a word out of a string, or you want to grab the first couple of characters out of a string or something like that. So, okay, that's indexing into strings, that's length of strings, that's different types of strings, and converting number strings back into numbers. So the next data type is going to be arrays, which is a collection of different types of variables. So I create an array by using the concatenate function or the C function, which is basically just going to create a collection of the different pieces of data into a single place. So I can an array is now a set of 1, 2, 3, 4. And you can contain as many different types of as many pieces of data as you want in this. So I can make this, like 1,000 different numbers, like numbers 1 through 1,000 in ascending order. There are, but keep in mind that an array can only have a single type of data inside of it. So you can't have an array that is numbers and strings. So for example, that is going to get converted from it's going to get converted into a character array versus which is different from a number array in that it contains characters versus numbers, or versus the numeric data. Now, the important part about arrays is how to index them. They're a great way to store data or large sets of data that are related to each other, but you need to be able to access that data for it to be useful. So for example, let's say this one, you want to access the one in this in array. An array 1 would get you the first number in that array. Now, then if you want to do 2, 3, 4, and let's set a new array. That's just to show you what I mean, because otherwise it may look like it's just returning the number that I put into it. That's going to be 6, which is the second number in that array. So, okay, now that we've got this, another important thing is to get the length of an array, to know how many things are stored inside an array. So you could do that using this length function, which will just tell you the number of things stored in it. 4 in this case, 5, 6, 7, 8 is 4 separate numbers. And that's sort of going to be helpful for what we're about to talk about, which is indexing arrays. So I showed you how to get individual numbers out of an array. But let's say you wanted to get the first 2 numbers out of an array. Well, there are a couple of different ways to do that. First of all, the first one, the simplest, is just what I call colon indexing, which is to essentially say, okay, 1 to 2. So that will get you the first 2 elements. It'll get you the element starting at 1, and the elements 2, and all the elements to the element ending at 2. So for example, if I were to do 1:3, that give me the first 3 elements. If I were to do 2:3, that give me the element starting from 2 going to 3, or 2:4 would give me the element starting at 2 going to 4. So 2, 3, and 4. This is like the easiest way to get, if you want to grab if you want to grab a couple, like the first 10 samples from an array or something like that, you do, colon indexing is one of the easiest ways. The next way to do array indexing is to use what I call array subindexes. So let's say I wanted to get the first and the last element from this new array. What I would do is I make a new array that is just 1 and 4, the first and the last indexes of this array. And I would go, okay, new array, and then you pass it the other array, the array that is like, the indexes you want to grab, and it'll get you the those values of the new array that are at those indexes. So you can construct an array that are just numbers that are all the specific indexes you want to grab, and then pass that to inside of this square brackets to get the indexes of this other array. And that brings up one important point. You index into arrays using square brackets, which is different from the curly bracket or the circular bracket or the parentheses that we use for function calls and stuff like that. Okay, so then the last way to do array indexing is something that is sort of a subset of this subsequence or this array subsequence indexing. And that would be using the seek function. So let's say we had an array that was some set of numbers. We had, it's 9 long, and I wanted to get every other element of it. So I want to get the first element, the third element, the fifth element, the seventh element, the ninth element of it. Well, I could construct that going, okay, I want the 1, 3, 5, 7, 9. Let's say it was 1,000 long. I want to get, all the odd numbered elements. Well, that would take a while to type out individually. So what I can do is I can say an array to be a sequence, use a seek function to create an array that is all the indexes I want to grab. So, and the seek function takes as passing the first number, the number you want to start with, the number you want to end with, which is going to be 9, and then the how much you want to jump by. So, for example, going 2 would mean that I would go 1, 3, 5, 7, 9. Going 3 would mean I'd go 1, 4, 7, and then because because the next number in that sequence would be 10, and 9 is below 10, it would stop there at 7. And you can kind of see how this goes, where I can go 1 through, I can go like by 5s, by 6s, whatever. So now target indexes, by using this function, now target indexes is going to be all the indexes that we actually want. And so now we go that's going to grab us 1, 2, 4, 9, and 11, which is the first, third, fifth, seventh, and ninth element of this array. Okay, so that is the basics of arrays. We're now going to start talking about a slightly more advanced data type called matrices. So if you're familiar with that, if you've taken some advanced, maybe linear algebra or calculus, you may have talked about matrices. And matrices are essentially, so if you think of arrays as a one-dimensional collection of data, so that is like, it's you can, like, if you can go along a number line, there's the first index, the second index, the third index, the fourth index. So that's one-dimensional. Matrices are a two-dimensional way to store data. So, and the way that you construct a matrix is simply matrix function, where you pass it the data you want to use, and then you pass it the number of rows you want to use, the number of columns you want to use, and row and column. And so what this matrix now is it's going to be a two-dimensional, like I said, a two-dimensional representation of your data. So if you look there, you're going to see it's 1, 2, 3, 4 in, sort of going down, and then right when you get to the bottom, and like I said, two-dimensional. So this is going to be important, because say you have like a sequence of samples that can be described by two variables. So say, for example, you took the temperature and the humidity every day for a week. Let's say, you did that's that. And let's, I'm going to make up some data. Let's go 20, 2, 21, 30, 0.5, 30, 0.6. And then let's say you did, let's say it dropped down drastically down to 10, 0.1 as your humidity. And then we do n row 2. You want 2 rows, and you're going to have 7 columns because, sorry, I made a slight error there. Let's actually set the scattered matrix to this. So now we have a matrix, and if you click on this variable, it'll show up here. It'll show up in this variable, or in the normally it's the script view. But you can see here that we've got this first, row, because rows are traveling right and left. We'll be traversing a row, traveling up and down, and be traversing a column. But this first row is going to be the temperatures on the 7 days that you gathered data, and the second row is going to be the humidities on the days that you gathered data. And the first column is going to be the humidity and the temperature you gathered on the first day, and the final column is going to be the temperature and humidity you gathered on the final day. The sixth column is the temperature and humidity you gathered on the sixth day, etc. So this is like a really convenient way to store data, because you can kind of tell how stuff is associated, and it's really easy to sort of like look, okay, well, the temperature is 21 degrees, the humidity was 0.3, something like that. So the important bit here is that essentially anything you can do with arrays, you can also do with matrices, but you sort of have to work in 2 dimensions. So for example, let's look at the we're just going to be using colon indexing here, just because it's a little easier for me to do right now. Let's say we want to grab just the first day, the samples from the first day. So we go, do this is to go just get a matrix. Okay. So now let's say we wanted to do, like I said, the samples you got on the first day. that's going to be colon, comma, one, or sorry, comma, one, nothing, comma, one, which is essentially saying we want to grab the first, all rows and the first column. So, and if we want to grab just the first element, just the temperature we got on the day, we do one comma one. And if we want to grab all of the temperatures, we do one comma nothing, which grab the first row and then everything from the first row. Versus 1 comma 1 is the first row and the first column. And if we wanted to do 2 comma 1, we can grab the first, the second row, first column, etc. And you could do you can grab all of the humidity data just by doing, or sorry, not all the humidity data. You can do all the humidity data by going 2 comma nothing or 2 comma everything, and that would get you all of the humidity samples you got across the 7 days. So, okay, that is how you index into matrices, which is kind of important stuff. And so that's all that we're going to be covering for today. Thank you very much and have a good day.